Yeah. Design of S-R Latch using NAND-gate. In the last class, we have designed S-R Latch using NAND. Then already we know why should we design a S-R Latch using NAND. Only the simple thing, as I told you, whenever you go for NOR gate, it is taking more power. To avoid that problem, we are going to use NAND gate. So now onwards, we are going to use NAND gates to design any flip-flops and latches. Got it? NAND gates require NAND gate requires less power than NOR gates. So that we are going to prefer NAND gates for sequential logic circuits. So just observe previous class and this class. Just I replaced NOR gates with NAND gates. Same logic circuit I have taken. Only I have changed only in place of NOR gate I have taken NAND gates. And one more difference also you can observe. Whenever you want to design S-R latch using NOR gates, you should take first R, then you should take next S. Are you clear? But now onwards, we are using NAND gates. You take first S and R. This is another difference. Are you clear? Clear. Same flow we are going to continue until this unit actually. So this diagram is very important, base diagram. We are going to add small circuits every time. Okay? Clear? So now just observe. Again, I will repeat my definition for sequential logic circuit. What is sequential logic circuit? Output always depending on the current, means present input and present state. No, so if I want to calculate, my Qn plus 1 means next state. This is a next state. This is a present state. This is a present input. So if I want to calculate next state, that must be a depending on the present input and present state. This is a direct port. This is a complement port. Straight port and complement port. Are you clear? This already we know. So same definition we are going to continue until this unit, because we are designing a sequential logic circuit procedure. This is a procedure. So now we are going to design the truth table, because you know inputs, you know outputs, and you know the present states also. Correct? So tell me how to design a truth table for this. Truth table. Tell me. As per the previous experience, yesterday we have done, right? Now tell me, what is the inputs we should consider? Yes, R. Next. Because it is a present state. Because Next state depending on present input and present state. This is a present inputs. This is a present state, that is QN. Yes or no? Yes or no? Then we are going to produce next state. Correct? Correct. Now this is a structure of the truth table. This is the structure of the truth table. Now we should fill the values based on the analysis of the given logic circuit of the S-R Latch using NAND-gate. Are you following? So as per the previous experience, you know, the present state is always as per the previous experience, the present state is always present state is always, just go back, check. Present state always do not care condition. Yes or no? We have done already, we have learned. Yes or no? Means 0, 0, present state is always either 0 or 1. Just check it. Yes or no? Either 0 it will be produced same, or 1 of it will be produced. So do not care condition you can take. So based on this previous experience, then we can design your truth table. 0, 1, do not care. 1, 0, do not care. 1, 1, do not. Correct? Correct. That is what continuity is required. If you are absent in the previous class, things are somewhat harder. That last girl, stand up. So you come regular, then only you can understand. You cannot get any laugh. If you are not regular, you don't know anything, maybe you can feel uncomfortable. Do not care condition. It is applicable to you also. Do not care condition. So now tell me, now you should calculate Qn plus 1, correct? We should calculate or not? Now tell me how to calculate. What are the conditions are possible? The first condition, S equals 0, R equals to 0. Right? Now how to calculate? Always you should calculate next state, not present state. Don't feel, sir, this is output, this is why I am going to calculate Qn. Here, not like combination circuit. Here it is a sequential logic circuit. Sequential logic circuit, always the output is depending on the present input and present state. This is a present state. Don't expect this output. In a combination logic circuit, you thought this is input, this is output. But here this is a different circuit, different phenomena and procedure. Are you clear? So Qn plus 1 equals to, what is going to happen? S equal to 0, R equal to 0. Now S value is 0. Yes or no? 0. Yes or no? Then 0. This is a NAND gate. So multiplication, correct? Into, then what is one more input? Yes or no? This is one more input, right? What is that? Qn bar. Then this is NAND gate, right? NAND gate, right? Old bar, correct? Is it right? Is it right? So 0 into something? 0. Then what is going to happen? 0 bar. 0 bar is what? 1. So it is representing 1. So good, it is representing 1. Okay, okay, happy. But S equal to 0, R equal to 0. Both are equal. S equal to R is possible here because S equal to 0, R equal to 0. Means maybe if you get R equals to same value, so there is a problem. That is why what we need to check, you need to check complement for this. Means complement port also you need to check. Where we need to check? Whenever S equal to R value is there, you need to check complement port also in this case, as per the previous class experience. Are you clear? Why? Both should be different. Why? Your inputs are same. Are you clear? So that is you need to check. So what is going to happen? Qn plus 1. Actually, if R value is 1, for example, no need to check complement port because we got value already. So no need to check any complement. Why? We got the value. But here what happened? S and R pointing to same value. Are you clear? So we need to check complement port also. Qn plus 1 bar. Tell me what is the Qn plus 1 bar? Then again, this is a Qn plus 1 bar. Then what is going to happen? R value. What is R value? 0 into, then one more input is what? Here, 6. So Qn, correct? Then this is whole bar. What is going to happen? 0 bar. Then it is 1. Now check. Qn plus 1 and Qn plus 1 bar is pointing to 1. Is it possible? Tell me. The number and its complement is pointing to same. So it is indeterminate condition. Yes or no? It is not possible. So it is a indeterminate condition. What state it is? It is a indeterminate state. Are you following? Are you following? Right. Then go to second statement. Second phase. What is second phase? S equal to 0, R equals to 1. Then we need to check in this condition, in this case, Qn plus 1. Now tell me, again you need to calculate Qn plus 1. Here S value is 0, because we are calculating this, S value is 0. Then what is going to happen here? 0 dot Qn bar, whole bar, then this is 1. This is 1. Now, is it required to calculate complement port? Is it required to calculate complement port? Yes or no? Is it required to calculate complement port in this case? No, because we got 1 and R value is also different. So no need to calculate. Are you clear? So 1 is what? Set or reset? This is a set condition. Are you following? Yes. Now coming to, please try to understand flow, because all flip-flops we are going to do like this only. So third case. What is third case? S equals to 1, R equals to 0. Now tell me, Qn plus 1 equals to, S equals to 1 now. So 1 into Qn bar, whole bar. 1 into something means that one only. Means what we will get? Qn is output. Yes, sir? Then we need to check complement here, because we are not get any set or reset value. So we need to go with the complement. Are clear? Conditions you need to justify. So just check complement port now. What is the complement port? Qn plus 1 bar. So now tell me what is going to happen. Your R value is 0. So 0 into, so one more input is present current state. What is that? Qn whole bar. So 0 into Qn whole bar. What happened? 0 bar. Then what you will get? 1. This is 0. Now something we are missing anywhere. Just check it. Here S equal to 1, R equal to 0. So S equal to 1, R equal to 0. So 0, it is complement, right? So what you got with complement? 1. So with respect to Qn plus 1 complement. What we need to calculate? Qn plus 1. What is the Qn plus 1? 0. Are you clear? If Qn plus 1 complement is 1, what is the Qn plus 1? 0. Clear? So this is 0. This is reset condition. Following? Clear? Then fourth. S equals to 1, R equals to 1. When we need to check complement is very important. Okay? Right. Qn plus 1 equals to, what is going to happen? 1 into Qn bar, whole bar. What is going to happen here? Qn. So we need to go with the complement port now. Because S equal to 1, R equal to 1. Then Qn plus 1 bar equals to, again 1 into Qn whole bar. This is a Qn bar. So when I am giving a Qn plus 1 is Qn plus 1 bar equal to Qn bar. Yes or no? So there is a no change condition. Here what is this here? Qn. Are you clear? I have done same whatever I did yesterday. Same thing I have done. Only we have used here what? NAND gates. Okay, last class we have taken NOR gates.